other technique that we need to learn in section 6.3 is on minimizing with greater than constraints. And so here we have some constraints. You notice that they have greater thans this time, and we have our optimizing function. It looks a lot like what we did in section 6.2, but the constraints have greater thans. We've got some new steps that we need to go by. On our formula sheet, down here at the end, you see minimizing with greater than constraints. We'll be following these three steps. Step 1, here's how we do a matrix for forming the dual. We're going to take the constraints and just take the numbers and leave them in their same positions. We're going to take the minimizing function and organize it so that the x1s are lined up and the x2s are lined up, and put our variable under the constant column. That's the matrix for forming the dual. Then we're going to take that matrix and do a process called the transpose. The transpose of a matrix means to interchange the rows and the columns. So we're going to take the first column and write it as a row. First column becomes first row. Second column becomes second row. Third column becomes third row. Notice that the letter representing what we're trying to minimize is still in its same position. We're going to relabel this matrix with new variables. Traditionally, we'll use y's. It doesn't matter what the variables are as long as they're not x's like we started with. And so we'll label the columns y1 and y2. The third column is still going to be constants. Then, for step 3, we want to rewrite this matrix similar to how we did it in step 1 back into inequalities and functions. So for the first row, we're going to write the inequality 2y1 plus 6y2 is less than or equal to 18. Second row becomes the inequality. Third row is our new optimizing function. And so now we have constraints and optimizing functions just like what we had in section 6.2, and we indeed do the same process that we did in section 6.2. I'll go through that with you for this problem. The three steps look like this. Rewrite the constraints with slack variables. Notice this time, instead of s's for our slack variables, we're using x's. Rewrite the optimizing function with all of the variables on the other side. That means we got the negatives. See how everything is lined up on the y1s and y2s. Then we want to write that into a matrix. A column for y1, column for y2, column for x1, column for x2, column for g, and column for the constants. We've already done this several times, so I'll put the numbers in there kind of quickly. And then we want to use our Simplex program in order to find the right solutions. So we will take out our calculator. We will go to our second matrix, edit, matrix A, 3 by 6, and type in our numbers. Second, quit. From the home screen, we program Simplex and enter. already typed in our matrix, so we're okay. Press enter again. Now we can see that the negative 36 is the most negative number in the bottom row, and that is in column 2. That is our pivot column. Go do a divide, column 2, and find the smallest positive number. That is in row 2. And so now we need to do a pivot on row 2, column 2. And have a look. We still have a negative number in column 1. We will do a divide. Pivot column is 1. Smallest number is 6, row 1. And so we'll pivot row 1, column 1. We'll have a look at the new matrix. No more negatives in the bottom row. So we're through with the matrix. Okay, after doing the simplex operations using the program on our calculator, we end up with the final simplex matrix, which looks like this. In the past, we've been looking for this pattern of 1s and 0s. We've said the 1 in this column and 0s below tell us that this is our answer. Well, I guess that is indeed the answer for y1. The only issue is we're not looking for y1. We're looking for x1 and x2. And so we have a new interpretation. So here's how we find our answers when we've done the minimization process using the dual. We labeled the slack variables by x1 and x2. Where the x1 column is, we look at the number at the bottom of the x1 column, and that's our answer for x1. At the bottom of the x2 column is our answer for x2, and the value of the optimized variable is still the number in the bottom right.